I'm Tom Harding. I help maintain Bitcoin XT. I'm going to discuss the relay dynamics of unconfirmed transactions and the alerts in the context of native respend resistance, which is what we're talking about for the BCH network, although there's not really anything specific to BCH. We heard about proofs. Proofs can work, and if anyone deploys them for Bitcoin Cash, I have some suggestions on how to do it well. However, I'm not a fan of proofs because the network traffic patterns are much more complex than simple relay. In the case of a symmetric proof, which what I think we have, there's at least one new message type, and it's proposed to be another inventory type on the level of blocks and transactions, which is a major networking change. Because the design that's on the table has a degraded user experience compared to simple relay. Because of the lack of outputs in the proof, it leads to not being able to alert in half of the situations immediately. I think that's a serious problem. And because against professional attacks, the proofs do not improve security versus simple relay. For the reason that it's up to the attacker. It comes down to one party has a privileged position in the game. One party knows before anyone else that a double spend is being attempted. That person is, of course, the attacker. The attacker has more control than anyone else over which nodes are first to receive one transaction, which nodes are first to receive another, and which nodes might receive a third. He himself can be the first to generate and transmit proofs wherever he wants to. And in the case of an asymmetric proof, which is one that doesn't have both transactions in it, which we had earlier been proposed, he also controls which transaction is seen as a double spend, which is a really bad idea. You don't want random third parties trying to identify which transaction is a double spend. He can release all these nearly simultaneously or with whatever timing he wants. That's just a response comment, really. Okay. So I won't go over what double spends are. I'll assume, especially because we've had a refresher already. The different solutions for zero-conf reliability distinguish themselves by how decentralized they are. No other existing or proposed zero-conf solution is substantially permissionless or decentralized or censorship resistant than the alerts, which includes proofs or relaying, just simply relaying the transaction. That's an alert that is, it should be obvious from the talks we had already. It's the fastest thing you can do. It doesn't require achieving a consensus amongst a bunch of other nodes, and time is of the absolute essence. We talk about 5 seconds. I've heard that 3 seconds is standard now for credit card transactions, and we should expect it to get shorter. And the standard for us should be of how fast. It should be as fast as possible, as fast as humanly possible, computerally possible, and it should continue to get faster. But it is decentralized and permissionless because we're talking about nodes doing this. We're not talking about introducing any new centralized parties. It's also secure and private because it doesn't change Bitcoin very much. And of course, it's not as secure and private as OneConf. And I have a slide later that talks about trade-offs between privacy and various other things. I happen to agree with what Xavier said yesterday, which is that is it really worth sacrificing any zero-conf performance and speed for privacy? And if it is, I believe that it needs to be a user choice. And if it's not, then everything should just be as fast as possible. So we're here to try and make Bitcoin better for all users. There are existing services that mitigate zero-conf risk, such as GAP 600, and they're excellent, and they'll remain excellent. They will be enhanced by improvements that we make to the protocol. Zero-conf security in Bitcoin is a belt and suspenders and everything else situation. We can do multiple things. Proofs and transaction relay have to exist. They can both exist. It doesn't mean you don't want to have complete adoption of both, but they're not really alternatives to each other. A scheme like what Ameni has proposed can coexist with all of that and be done also. You might want to tie in so you don't make the user make too many choices. It's either like protect me or don't protect me. And so we'll have multiple layers of protection, both within the protocol and by service providers. And I think that's really exciting. Okay, so the way I see the design goal of native respend resistance is we're dealing in a new space to keep the essential properties of Bitcoin. Every node needs to decide for itself based on its own independent observation what the truth is. This is how a consensus works on the blockchain using the global signal of proof of work. Nodes can do something similar to make zero-conf reliable using their own observations of another global signal, which is time. It's impossible to convince a remote peer that it receives any message earlier than it actually received it. You can delay the earliness of receipt time of a message is a direct observation involving no trust in peers. Of course, the peers can influence lateness by just delaying sending it to you, but there's a limit, physical limit to how fast they can send it. And this is why we want the network to be transparent as possible to both protected transactions and alerts. A highly developed system of global clocks dedicated to synchronizing global clocks called NTP, maybe there's other systems, is available. But we don't even need to use that system because the gap time between a transaction and alert is the key driver of making this system work. And for that, all we really need to use is the independent timekeeping device that's built into every computer and every phone. Every device is able to measure the time difference between two events to a much higher degree of accuracy than is required for our application. So it really is leveraging an independent observation that can be made by every different node in the network. And the first scene, this is why the first scene rule is so successful for such a simple system. The first scene rule is a fundamentally sound design, but what we need to do is remove the obstacles and streamline a few things. Okay. I don't want to go too fast or too slow. Alerts are required. Sorry. Okay, so this native respend resistance is two things. It's immediate and reliable relay of the protected transactions. We heard a suggestion earlier that a protected transaction is any standard transaction that pays a fee of a certain level. That's one definition. For such a transaction, for whatever is a protected transaction, there has to be no artificial delays and no more total delay than other immediate relays, other things that are sent along. So you can have a little delay. I know some people have been concerned that you don't want to do everything exactly immediately. And you need to have an exact specification for what's protected because the merchant needs to know what he's looking for so he can quickly decide and automate it in software whether that transaction should be relied on or not. I'll skip over a few things. The alert needs the same immediate treatment as the original. The alert is, if the alert is simply another conflicting protected transaction, then that's extremely simple. If it's a new type of inventory, it's quite a bit more complex, but it needs to be relayed as fast as possible. Alerts are required so that the absence of a double spend alert is meaningful. Okay, fee, there's two great independent variables that I don't think are reducible in zero-conf. And one is the fee. Fees are dynamic. They change based on network conditions. I think it's always going to be the case that people interacting have to dynamically set their expectation of what kind of fee is likely to confirm. Nothing we're talking about here is going to guarantee that anything gets mined. Alerting on double spends, as Tom Zander said, is pointing out a bad situation and looking for the absence of that bad situation. It's not saying, oh, I met all the criteria, so I'm getting mined in the next block. That's not true unless you pay a high enough fee for the current network conditions. And the respend gap T, which is the amount of time that a merchant waits to feel safe, is also going to be a dynamic variable because things get faster, network conditions change, and preferences change. So I used to think that you could specify a global thing and we could say we'll build a 5-second system or a 3-second system, but now I think that T, which is the time that needs to be waited, is going to vary from place to place. One thing that's really important that isn't necessarily perfectly immediately obvious is that the miner's job is not to mess around with any kind of respend gap. Their job is to mine the first transaction, even if there was another one just a little bit later. And the reason for that is because they may have seen the gap smaller than someone else did. So if you let them try play games with if they start playing games with the gap, then they'll actually make it worse, and the attacker can exploit that. Okay, I think that may be all. You could have a global service that defines you have services that will suggest what the current fees are, and you could have services that suggest what a current value of T would be appropriate. But it would just be a suggestion. It wouldn't be something that was built in or that everybody had to use. Okay, so what I did, I think it's great that we have a variety of analytical approaches coming in. We had a lot of simulation, which is great. We have live testing going on. We have BU and XT relaying respends, and we have measurement going on. Several websites where we can see what's actually happening. This is a third approach what I did with an analytical modeling, which has the advantage of being able to tweak things just with a few keystrokes and instead of having to deploy a test network. But it has drawbacks too. But what I did, so this is a way to model the entire network by modeling transaction propagation. And so I have two of these. These are exactly the same, and this represents two transactions flying out on the network. One would be the first one sent, and the other would be the second. And then we want to examine the behavior of what the entire network sees as far as the gap between those two, because this is the critical parameter for the merchant behavior. And so I have a little equation here. That first transaction, I had this sort of the same chart. This is modeling that one transaction itself, how long it takes to get to one other node in the network. And that could be, it's never going to get there immediately. Most of the time, this is modeling a mean of 1.11. Or later, I use a value of 0.75, which is where the Bitcoin network was at its greatest before they made it worse. And then there's a long tail on it. So if you take one transaction, and then you subtract the other one, whatever random value is seen by one particular node, then you get the gap. So this minus this equals the gap. The gap has its own distribution, which is a statistical combination of those two. And it looks like this. So it's kind of like a really pointy type of symmetric distribution. And this is what will one node on the network, but you can use this and pick a random variable for every node on the network by sampling the distribution. They'll most likely see no gap. If they were transmitted at the same time, they'll most likely see them at the same time or close to each other, and then there might be a gap. It could be positive or negative, and it could be very long, but it's most likely to be centralized. So this is just an outgrowth of the earlier assumption of what is the distribution of individual propagation time. So what we can do with this is actually then pull samples out of it for what kind of value of T is going to work. And so what we do is we say, well, if I set a time of plus or minus 2 seconds, like if I set t to be 2, then you're going to be measuring, you're going to be taking an integral from here over to here. And this that's how much of it was 2 seconds or more, and the 2 seconds or less. And then that proportion of the area of the whole thing, which is 1, is the probability that you saw a gap that big. So we need to set, then we can make a little chart like this. This is if we sit, based on the assumption of, it all comes from the assumption of that median being, this is for 0.75 median. So if it's like the Bitcoin network was when it was at its greatest, and that shape of that curve is accurate, then these are the timed t's and the probability that you're going to see that, that you won't see it within that amount of time. So for example, if I set the gap to 5 seconds that we've been talking about, 3% of the nodes are going to see transactions that were transmitted simultaneously 5 seconds or more apart. 3% of the time it will have a false reading because of network variation, because the one transaction don't go exactly the same speed everywhere. So if you set it to 0, it's 50% likely to be either first or last. By the way, this is basically how Dash works. Because what Dash does is they have, I think, 19 nodes, or maybe it's all the master nodes. So 20, however many they have, 23, no, that's Bitcoin Core. I mean LBTC. If however many master nodes they have, they just vote on which one they saw first. And they're using 50%. They don't use a gap, at least when I last checked. Which is, they're effectively doing an arbitrary thing. They're reaching consensus, but they're picking whichever one a majority of nodes, and I think it only has to be a simple majority, saw first. So these random things are going to not pick the one that was transmitted first. And for a fast respin where they're transmitted immediately at the same time, it's a good point that it doesn't matter which one was first. It just matters that it's conflicted. But then you have to use a global signal. And the global signal is to start from the one that was transmitted first. So if you go to 10 seconds, I happen to think it's probably the conditions on the network are better than 0.75. And that's what we see from our live tests. From our live tests, you very seldom see a fast respin successful over 1 second. Which seems like this would predict a 20% chance, so that suggests to me that transactions are going faster than 0.75 seconds. But
could it be, though, that the miners are better connected than the overlays?
Yeah, well, there's certainly complexities in how the network looks. Yeah, this is assuming it's the same. But the network is so complex, it's so highly dimensionally connected that, I mean, you look at a 2D graph and you think, oh, this node's far from this node, but they could easily be directly connected. And the miners are certainly directly connected, and lots of nodes probably have a connection into that network somewhere. But then there are areas that are less, and the distribution of long tail is actually observed by the sampling that Christian Decker did. But you're probably right, the ones that saw a very long time are probably not miners, and so that's another reason to believe that the actual performance is better, because the miners are the most important. The miner is going to mine what he saw first. So it's important that whatever the merchant decided agrees with that.
Yes, sorry.
Quick question?
One thing I don't understand is because here you say two transactions are transmitted at the same time, and then you look at how well they distribute through the network. But in the case of the double spend, you're asking if one goes from the miner to the merchant and one goes from the merchant to the miner, which is the same path, right? Only the other direction. So doesn't that make it already much less? Or am I saying something weird here?
No. I just want to label this correctly. What this is the probability that any node sees the gap at a certain level. So the merchant is going to he sets the gap. So he will say, I require 5 seconds. And then the question is whether the miner sees the same transaction first. Whether he's in the same, whether he saw that same thing or not. And the probability that he sees that same, it's equivalent to this formulation of it going the other way. He would see that gap would develop. If the miner saw them at exactly the same time, well, think about it flipped the other way. If the miner saw them at exactly the same time, that would be the minimal case for getting the right answer, right? So then the chance that it had gone the other way and he went to the guy who measured a 5-second gap was 3%. Okay. Yeah, and it's 3% because this is for one side of the distribution, which is the correct thing. It can be as far as you want the other way, and it's fine. Okay. So I don't know, does this make some degree of sense? Okay, because it's meant to be just a formula you can plug in, or a model you can plug in, because you could change the parameters. Miners should never include something they saw as a respend in their block. So this was the super standard immediate transactions was a proposal that I put out that tried to specify everything you'd have to do to be able to rely on for sure rely on zero-conf transactions today. And it is a specific suggestion, but it's also just a starting point for what the important issues are. So I think just to go through these are someone earlier put up the rules for how to behave, and it has to do things like relay, the first respend. This is the list of what makes a transaction super standard. And it's things that we've been sort of discussing. One is that it's regular standard. That's a minimum. That's why it's called super standard. Regular standard has to be in all the clients, and it's not actually that simple, but on the good side, all the clients are basically the same for what standard is. So it's not that complicated, and there is the issue of how that evolves over time, which is also an issue for anything that defines what's going to be protected. In addition, now this is where I sort of caved, because when I put out the first version of this proposal, I said it needs to have only one input, which many mentioned yesterday, and it needs to have only a confirmed input. And then if you do that, if you say it has to be confirmed, then your class of protected transactions also is immune to malleability attacks. And that seems like it might be a good idea. It rubbed everybody the wrong way, though, because it's a burden. It's a burden on wallets to make sure that they have generated it, and sometimes they don't have it. So that's one of our decisions, is whether we say that, we make that part of what's required, or we say, hey, by the way, this doesn't protect you from malleability attacks, which are really easy to do. So maybe that one would go back. Also, and the requirement to only have one input, I believe, is actually mitigated by changing the way that we track what's already been alerted for. It's an anti-DOS thing. The reason is if you have one transaction, that you pay someone with a transaction that has 1,000 UTXOs being spent, then you're enabling 1,000 double spend proofs or 1,000 other transactions to be relayed against it. And that's not good. So that was why we limited it. But I do believe that we found a way to fix that by changing the basis for what we call already alerted. Instead of tracking the individual UTXO, we just track the specific transaction that was alerted against. And the reason there is because then the transaction can be confirmed and it has to be paid for. So you only allow one transaction per transaction, and so then you don't have all the other free alerts getting sent out. So we could drop that one. That was another one that was in the first version. So SI says, this is how SI tries to compete with the idea of a proof. It just says the transaction has to be smaller than 2,000 bytes. Now, because even I was trying to point out earlier that any protected class is going to have a limit to be reliable. It's going to have a limit on the size of transaction that it protects. So if you put that limit, because the rules for the alert, and if the alert is a transaction, then the rules for the alert and the original transaction can be the same, and they both have to be 2,000 bytes. That's a proposal that I think is a good one. Then this is also an optional setting this bit. This bit is a way for the transaction author to say, I don't care about privacy, relay me immediately. And if you didn't set this bit, we don't relay alerts, because nobody should be relying on it. This is an answer, a positive answer to the next question I was going to ask, was should there be an instant checkbox? If there is an instant checkbox, then we can condition all kinds of things on it. Whether to put an on-many thing in it, whether to issue alerts against it, or just don't bother. So if there's not going to be an SI checkbox or a instant checkbox, then we can also make it work, but the system may be more brittle. And here's the concept of expiration. This hasn't been mentioned today, but it's another yesterday, this is another very important thing that has to be solved. Currently, when does the protection end? If somebody tries to double spend a UTXO, does that mean that UTXO can never be spent? Well, that can't be the case. I mean, maybe I guess it is one option. It's just burn.
Donation to everybody.
Yeah, we burn it or something and give it to donate to ABC. No, and so the protection interval has to be well defined also. Now you could have edge effects at the backside of it, so you would have to be well defined, and then people should stop relying on it well before that point. And what we suggested, with some reasoning, after discussing it briefly, was that we would wait 2 blocks plus 1 hour of receipt time. So you would drop the protection, and by 2 blocks, that is based on receive time. So you got the transaction, that's time 0. Now you got 1 block after that. Locally, you received it, so nodes could still disagree. Anytime you're using local time, which we have to for this, we're not using block timestamps, it's not possible for transactions, that you would wait for 2 blocks to be received later that wind up in the blockchain, and 1 hour after that. So it would be like a minimum of 1 hour and a maximum of, well, there's no real maximum, but generally about 1 hour and 20 minutes, or yeah.
Sorry,
Sure, quick question.
Can you clarify a little bit what exactly does the protected period do? Like what do nodes do with that information?
Oh, it means that if it's that old, you shouldn't, you shouldn't treat it like something that can't be, that miners shouldn't be afraid to confirm the alternate, right? It would let you respend it after 1 hour and 20 minutes.
But if miner got it first thing, it would mine it anyway, right?
No, but, but they haven't for some reason.
Right, but
This is just in case they haven't.
Emergency case of what happens if the transaction just gets orphaned and it doesn't get mined, it's sitting around.
Low fee would be the big case. If there's low fee, then when can I respend it? When should the miner feel it's okay to respend it? After 1 hour and 20 minutes. I've seen 2 hours suggestion. This needs to be part of the solution, because otherwise it's undefined, and that means it'll be unpredictable. So we can do much better than that by just defining it somehow. Let me see if I have any other comments about SI.
Does that sequence interfere with the CSV at all, or?
No, we did our level best that it doesn't. It doesn't overlap. It does. First, I was thinking of having it use the RBF flag, because that's what core would do. But we decided it was better not to. It's set in a negative way because the sequence is all ones lots of time, and so you will want to have it set off to mean something. So that's also just a suggestion. Could be any bit that works, but I would say try that one, see if that one works, because I think it will work. There's different pieces it doesn't conflict with the CSV actual interval. That's in those bits are somewhere else. And there's a CSV activation bit, that's not that one either.
Would the version field be inappropriate for that?
The TX version?
Yeah, instead of the sequence.
There was a reason for that. Well, the version has its own standardness considerations. I mean, it's essentially all claimed right now, whereas the sequence is started. And also, but you're right though, it's transaction level, not input level.
Yeah, that's what I didn't like about their RBF flag too. I mean, among other things, it's just weird to make a transaction level flag
Yeah. I think it's just because I didn't want to bite off, and maybe they didn't either, redefining what the TX version means. But that may be an option also. It's important that it be signed. If it's just a relay flag, then the guy who got it from you can just change it and make everyone else think it wasn't requested to be reliable. Okay. I think I got through all that.
Would that matter? If someone turns it off, everyone else is going to relay immediately. So the ones with the transaction that has the relay immediately bit set will tend to beat the transaction that doesn't have that.
Unless it's the first hop. If the one you broadcasted to changes the bit, then broadcasts it, then you're screwed. It's the first.
Presumably you would send it to more than one.
Well, I mean, isn't that the situation when you have when the customer, the customer wants to scan the merchant, right? And the merchant is usually, I guess, well connected, right? So he would be able to broadcast it to more nodes than.
You could.
I mean, yeah.
Yes.
I mean, if this becomes complex, maybe you should just have it on all the time by default if it passes the SSI standard.
Right, so that would be yeah. If the user wasn't going to have a checkbox, then you have to make decisions for all this stuff. You have to, you would have network relay everything immediately, which just seems reasonable to me, as well as you could also, another proposal for dealing with this is you could avoid having a super standard classification. It's possible to get rid of needing an SI class if we make a few changes. This one you could change standard. You could just say standard, maybe you compromise and say it's 10K or 5K, then that's probably good enough. And then you may not need to have this. Would it be great to not have an SI class? Well, then what you're doing is you're making it rely on standard, and like we already have the problem with standard where if we want to change it, it creates a problem for ZeroConf because of inconsistent relay rules. And so the one advantage of having an SI class is it could evolve slower than standard, because maybe we're doing innovation with standard transactions, but an SI class it's probably going to be just very simple. It's not meant for smart contracts or anything like that.
Just a quick question. Since this is really designed for ZeroConf, and the way that you design the checkbox is like enable privacy or I need privacy, wouldn't it make more sense to default to the immediate relay case and then change the bits only if you actually care for the delay so that it actually matches the option that you're presenting to the user? Do you have an objection to that?
Me, no.
Okay.
Yeah. Whether it's checked or not, or on if you don't see the checkbox, I guess it could be that decision could be made by each wallet. And then so there's trade-offs. We did a privacy versus speed trade-off that this would condition between. Do you want privacy or you want speed? There's complexity or speed. If it's a very simple kind of transaction versus I need to do something crazy. Flexibility versus speed. And then in some of the, in the Alimony, let's call it the Alimony thing, the insurance thing, it's capital, you would have to tie up capital for a little bit of time, and you have to pay more because it's going to be a bigger transaction, so there's trade-offs there too that checkbox could see. So yeah, I think the meta question is not what should the checkbox look like or do, but is there going to be do we think are we designing something that's going to have a checkbox, or are we just trying to just make some changes and not really disturb anybody? Okay, so this is my last slide. So I think the immediate next steps. This is a step along the process where looming out there is the question of what if miners misbehave. But I think it's absolutely the best thing that we're just ignoring that question right now, because we can fix things that in the world that assumes they behave, and it's not all hope is not lost. At least not in my mind. I think that we can. Especially once it becomes very clear when everybody knows that a miner starts putting things in that had 10-second delay. Everybody else saw a 10-second delay. Or I actually liked what imaginary username said, where you can just call them as a first step and see if you really have a problem. And then there's other things, and it's actually a very interesting area for research. So do we want to change standard processing or create a superstandard class? I see it as a question. Should there be a checkbox is another question. And should we relay the first respend or also design, implement, and deploy a proof design? I say also because, as I pointed out before, we can never assume no node can assume it won't see a respend transaction. Of course, some node has to create the proof. So he got 2 TX1s. And like I said earlier, the bad guy can send the 2 TX1, the TX1 takes 2 to as many nodes as he wants, and they're all going to see not the proof first. So I'll just end it there. That's some other things. Thank you.
First, great talk. And what I was curious is on the SI spec, is there a replacement option, kind of like imaginary username specified, where the super standard immediate transaction would ever do a replacement on a transaction, or are you leaving that out?
That's where he got the idea.
Right, that's what I was just confirming, because you didn't clarify it in your talk.
Yeah, it's not. This is just the qualities of a super standard transaction, so the spec also includes other things, and one of them is SI replacement. And this is also why what lots of people didn't like was the idea, because this is narrower than a standard transaction, it ends up replacing a standard well-propagating transaction that falls outside, like the 100K TX. Mm-hmm. So I say that's a good thing, because the 100K TX is an attack vector. The bad thing is you've created a way to reliably double spend, because if the 100K TX goes to the merchant and then can get replaced. And so what that means is it has to be, if you were going to do that, you would have to roll it out carefully. You would roll out all the other parts first, except for replacement, and then you have to add the replacement rule with a flag date and a warning not to rely on them until that happens.
And then your thoughts on, what happens if you have chained transactions on the original transaction that was replaced. How does that get handled? So
well,
you have your 100K transaction, somebody else chains a transaction that looks like...
Also, there could be multiple conflicts if there's multiple UTXOs, so they all have to get replaced, yes.
Okay.
No other way to do it.
First, it was some awesome analytical work. I like that. Thank you. I just want to point out that this is a different approach, and in an idealized world where we can actually deploy everything simultaneously all over the ecosystem, this is actually a really good approach that I like a lot, and where I get my inspiration from. But my personal concern is, of course, that we are on a decentralized network. Not everyone works in lockstep. Even if you tell them to, they don't. They give you the middle finger. That is why I dislike the part that Josh just pointed out. That and you also concur that some existing wallets and payments would get less secure because they now have a reliable way of getting double spent, and I think that anything that makes existing wallets, if they do nothing, they lose something, is a less desirable approach.
So the question is, do I agree?
Well, I mean, if the line can be drawn in a way that mitigates those concerns, we should explore that. Yeah.
Right. Well, I think it should be clear that changes are going to be required regardless of, and so since we're not going to be able to do it totally transparently, we should focus more on what's going to work the best in the short to medium term. It's not the replacement rule is an issue for you do replacement because of reverse respend, so that's only one class of attack. And like I said, the replacement rule could be delayed, doesn't have to come in first. What we could do, though, is immediately do replace by standard, because that's a good idea. So there are definitely ways to introduce it in stages.
Hi, yeah, so first of all, thanks for the nice talk. One comment I'd like to add here is that, so it seems to me that the changes needed on like a node level for supporting the super standard immediate transactions are not that big. I mean, it's like a couple of tests basically. And
we've implemented it already.
Right, so it seems like from the point of complexity, it seems like a very limited or pretty limited thing. And I mean, I personally would also go and say, okay, let's go and add the constraint of no unconfirmed inputs, as well as adding a SIG hash type constraint for other reasons. And
well, it's not necessary if you're using relay, but if you're going to use proof, you'd want to add that, yeah.
Yeah. So and it's just like I think that so I got this private comment that there's like more complexity, or like we discussed it, and there was like more complexity than on the wallet level. Like the wallets have to.
Either way, there's complexity.
So for example, if you have no if you have the requirement of no unconfirmed inputs, then you want to have the wallets to have this kind of like stash of UTXOs that they can reuse if you have like if you go through a shopping center and pay several merchants in a row, right? So
yes.
Can I comment quickly? Going to the shopping center, this doesn't work for SPV. The replacement of standard, yes, but the replacement of standard transactions, that works for SPV, but the whole relay of transactions is only for full nodes. SPV nodes will not notice these attacks at all.
But you are talking about SPV that is going to accept payment.
Yes.
Yeah. Because one thing that we never mentioned is that our merchant using SPV clients to accept payments, because it is a big thing that we didn't mention. And something, how are we going to...
They definitely are. SPV clients can be made to work with an alert scheme. The changes are required to the SPV client and probably to the full nodes for either one of the types of alerts that's been proposed.
You would need to query by input either way.
Yeah, but they're not complicated changes.
Yeah, I'll start here. I really like the double spend relay compared to the double spend proof, but I do have a question about how this exactly should behave. If I, as a node, if I get basically a double spend, first transaction A and then transaction B, and now I'm going to send to you an inventory of transaction B, shouldn't I be absolutely sure first that I send you the inventory for transaction A first, and if I don't know that, should I send you transaction A and B both? Because otherwise I might risk, you know,
for
swapping.
SPV you have to do that, because they may not have, they didn't get it.
But in general, otherwise you risk swapping, you know, what's the first and what's the second.
Well, so that may be an issue when we start parallelizing things. The way it was easy for us to implement, because when a transaction comes in, we check is a conflict in the mempool, so we know that it's in the mempool, it's been relayed, or it's in the queue.
Yeah, unless you have just a new node, new connection or anything. I mean,
sure, there'll be some node. If you turn a node on, it does not familiar with the history. Yeah, you would be possibly relay the second one, but remember the double spender can do that also.
Yeah,
and also we don't keep in our implementation we store the transactions that were transaction IDs that were alerted for. So that's how we remember. It doesn't go into the mempool. We don't save the double spend. We just say if we see another conflict and we see it conflicts with the same transaction, we don't relay it again.
Okay. Yeah.
Just a comment. The problem or the issue that I see with the replacement approach in all of the proposals is that the end result is it's going to be more double spends. There might be test double spends. There might be not actual double spends, not harmful double spends, but what that leads to is greater perceived risk. And in my opinion, that's the actual problem. The actual problem isn't the actual risk, it's the perceived risk. And so that's my general approach and concern with the replacement approach. And so the question, so it's just a comment. The question I wanted to ask, is there value, do you see value in this approach if we would not include replacement?
Well, to answer your comment first, I would say that I agree with the imaginary username that those non-standard transactions are already not reliable. So, and if are we going to worry that some weird guy who's probably just trying to make us look bad put a non-standard transaction out there and it got double spent, and then he writes a Reddit post that says he got? If we're going to worry about that, then what?
Doesn't this replace also standard transactions?
Well, you said both proposals. So,
I'm sorry. I was talking in general.
In the SI proposal, there is a flag day required if you're going to replace have a tighter protected band and you want to replace the old stuff. That's like a hard fork. It's similar to a hard fork. Some things that were reliable become not reliable. You have to really get the message out to the merchants and then the general population, or wallets, the general population also as much as possible.
In this case, does super standard not replace standard transactions?
After the fact.
Yeah.
So you could have a standard transaction and then someone...
Yeah, I'm not denying it. I'm saying that I am agreeing that it's kind of a big deal. So it needs to be.
Basically, implicitly, the super standard transactions become the new standard transactions and the other one becomes the non-standard.
Well, no. If that was what we're going to do, we would just change the standard transaction definition, which is another option.
Effectively, like the others become unreliable, right?
Well, it's not currently well defined what is a good zero-conf. So that's what we're talking about doing. To answer your other question, do I see value in not doing replacement? Yes. Yeah, we could leave the whole replacement thing out and just work on the fast respend aspect of it first. And that's what I suggested also, that you would delay the replacement, except for the S standard to S non-standard replacement. Seems like a great independent thing.
Essentially, if you leave out the replacement, you're essentially creating this a kind of a quality transactions indicating that this is highly, highly reliable.
Yeah, that makes a lot of sense. Yeah.
Yeah, and so the line where I draw it uses an existing line that already exists.
Cool. Thank you very much.
Thank you.